Hello, everybody. I am Andrea Keefe, the Meetings and Events Coordinator with IPC. I'm very excited to kick off today's webinar on highlights of IPC's 2018 PCB Technology Trends study. It's important to note that today's webinar is being recorded and will be sent to you via email a few business days concluding this webinar. If you have questions during today's webinar, please send them using the Q&A section on the webinar control panel. At the end of the webinar, we'll go through all of the questions and answers. Today, I am pleased to welcome Sharon Starr and Mike Carano to be our featured speakers. Sharon and Mike, thank you so much for being here. I'll now turn it over to you, Sharon.
Thank you very much, Andrea, and good morning, everyone. I'd like to start by giving you a little bit of background on the scope of the study. There we are. And first of all, I just want to say that as it's always been, we do this study globally and solicit contributions of data from companies all over the world. We have 74 companies providing data for this study, 52 OEMs and 22 PCB fabricators. We issued two separate surveys. The OEMs, we asked for their data about their use of emerging technologies and their technical requirements for PCBs. And the fabricators gave us data on their technology issues in PCB fabrication and on their capabilities, their technical capabilities. And as we've done before, we asked for the current state, issues and requirements, and their predictions for 2023, 5 years out. So the results give us some insight on the current state of PCB fabricators' ability to meet OEMs' needs, but also how we can expect these capabilities to change over the next 5 years. And as I mentioned, it's a global study. Our survey samples reflect IPC's membership base, which is a little more than half North American, but all regions of the world were represented. And in the study itself, we segment the data into two broad regions. One is North America and Europe. The other one is Africa and Asia. I should mention that there was only one survey respondent from Africa, so the data primarily represents Asia. We also asked the participants about their primary applications so that we could segment the data by a meaningful applications factor. And so we asked them to identify their primary products as being installed or mobile devices. And in the report, the data are also segmented by these two considerations. So before we begin, I'd like to first thank our technical advisors. Michael Carano, who's our speaker today, is the Vice President of Technology and Business Development at RBP Chemical Technology. And Denny Fritz, who is now an independent technology consultant. I'm sure both of those gentlemen are well known to you, and they certainly are to us at IPC. They've put in a tremendous amount of time and effort working with us on this project, helping us with everything from developing survey questions to reviewing the aggregate data and helping us understand the meaning of the results. So with that, I would like to turn it over to our speaker, Michael Carano.
Thank you, Sharon. And again, I'd like to welcome everyone to the webinar today. And again, thank you for joining us. So I'd like to take you through these next 30 minutes or so on the selected findings of the study. We picked some of the critical areas we thought you'd find of most interest, but as Sharon will tell you at the end of the report, there is going to be additional information in the full report that you may be able to obtain through the IPC store. Now, this came out loud and clear, as we've all heard about these things, artificial intelligence and the Internet of Things. I mean, these are nothing new, but they have reached fever pitch. And between the IoT, artificial intelligence, sensors, and neural networks, we're hearing more and more from the OEMs that these higher speed, higher frequency methods and means of communication, the need for high frequency materials, new circuit board designs, data transmission are all driving these particular technologies. So this is going to be a recurring theme throughout the presentation this morning, and how these actually affect the circuit board technology that we are going to be dealing with between now and 2023. So let's look at some of the OEMs, their product requirements. And you'll see there'll be a pretty good connection between what the fabricators are currently doing and what the OEMs are requiring. As you know, the OEMs, the major ones, are driving the technology, whether it's frequency, whether it's layer counts, wiring density, etc. And of course, that means that the fabricators have to find a way to build these things and build them reliably. The first key area that I think fits very well into telecommunication, internet infrastructure, neural networks, artificial intelligence, and of course the Internet of Things is the frequency at which signals will be transferred through the circuit board. And even though you can see there's a major change taking place both in North America, Europe, and of course Asia, Africa, you see a large percentage between now and 2023 moving up to beyond the 20 gigahertz range. Now, this is driving changes in copper foil, plating technologies, lamination, and interlayer treatment processes, as well as the materials themselves. And we'll be talking a little bit more about this. But it's quite clear there's move to higher frequencies in both major geographical regions, and that's not going to change anytime soon. As a matter of fact, we're hearing a number of companies are already pushing 77 gigahertz. So I expect this chart will look different in 2020 as well. You can't talk about technology and circuit board without the useful product life. You know, what life expectancy do the OEMs anticipate their needs will be in the products that they make? And obviously depends on the technology. Obviously, if it's a consumer item, it's an office item, it's probably somewhere less than 10 years. Mobile phones, the same thing. Smartphones, they're really not expected to last that long. However, when it comes to reliability, things that have to work 24/7, mission critical, the OEMs are pushing these greater than 25-year life expectancy, where they expect their parts, their circuit boards, their assemblies to last much longer. Now, you can see there's a somewhat of a disconnect or a difference between North America, Europe, and Asia, Africa. Obviously, currently, of the respondents that did respond to the survey, there was no one in the Asia, Africa response for 2018 that you see 0% there that expected greater than 25 years. But in North America and Europe, it was almost 6%, going to 16.1% in 2023. And that again reflects the type of technology, where the boards are used, and the environment in which they are used in, such as automotive, under the hood, military aero, etc. Now, that also takes us to the environments. You know, you hear of harsh use environment or ultra harsh use environments. This is always critical in understanding the type of circuit board and the assembly that you need to build. What materials do you need? What types of plating technologies, plating uniformity, plating thicknesses, surface finishes? You need to expect these boards to last under these very harsh conditions. And that could be automotive under the hood, satellites circling the globe, etc. Obviously, it's much different than the normal environments. But as you can see, harsh environment and ultra harsh use environments will be dominating the reliability requirements moving forward. So that means you're going to be building parts. If you are a fabricator or an assembler, you're going to be building these technologies to last under very tough conditions, high heat, vibration, not your normal indoor type performance products. So these are things that could be outside, base stations, internet infrastructure, satellite communication, automotive, etc. Now let's look at some of the circuit board requirements that were coming through loud and clear. Again, let's look at the common board thicknesses for flex, and rigid circuit boards. Obviously, in terms of rigid, across the geography, thicknesses are increasing. And this is a similar trend that Sharon's work found in 2016 when she published the 2016 study. Layer thicknesses were increasing, particularly on the rigid side. Again, this is a drive towards greater wiring density. You put more layers in, and that drives the rest of the technology. And of course, that presents challenges in terms of material selection and of course the performance of your lamination. How well does the layers hold together under these harsh use environments? So this is all being, well connected. Flexible circuits are also increasing in thickness, even though they tend to be thinner processes, as well as in Asia, you can see rigid flex is actually showing an increase, depending again on the sample that provided the data to us. But you can see the trends there quite clearly. But most likely, the thicknesses will increase as a percentage of rigid printed wiring boards. Flexible circuits will probably stay in a tighter range as they have the enabling technology based on the performance of the materials and the thinness that flexible circuits provide. Part and parcel to this in board thickness is layer counts. And you can see layer counts are increasing across the board. Again, between board thickness, layer counts, dielectric thicknesses, these are all driving wiring density. And of course, as you know, the semiconductor chips and the performance of semiconductors, the IOs are requiring greater wiring density. This, of course, is driving the layer counts upward. In addition, you'll see later on how that also is driving via sizes and the use of staggered and stacked vias. Looking also at layer counts for flexible circuits. Again, in Asia, you see very little, and also in North America, very little chain differences in the thicknesses greater than 8 layers. But it seems like the sweet spot is, for as far as the OEMs go, the sweet spot is between 3 and 8 layers. Whereas the fabricators themselves that participated in the study, their sweet spot tends to be 2 layers and then on up to the 3 8-layer counts. We don't expect that to change much, and most of the flexible circuits are typically 2 layers is what we're seeing today. Also looking at the rigid flex, if we take a look at the participating companies, the ones that did participate in the sample in terms of rigid flex, which again is a major enabler for military and aerospace, you see a large sweet spot between the 3 and 8-layer counts. A lot of those are 6 to 8 layers for this type of technology. In Asia, you don't typically see much, at least on the rigid flex side, again, in the sample that was provided the data, you don't see much differences or much change going beyond 2 layers in terms of rigid flex. But I'm sure there are some in the 3 to 8-layer range, but very small compared to North America and Europe. And again, that's driven by the end-use technology. Moving up the list here, this is the one area where we saw somewhat of a disconnect between those participants in the study. Again, the sample of those in our industry. Regardless, both the OEMs and the fabricators are expecting the need for drill capacity increase moving forward to 2023. Obviously, some of the fabricators that we know or we meet are currently drilling somewhere in the area of 70, 80,000 holes on some of their panels. But that is, again, kind of on the leading edge, if you will, or the state of the art, perhaps. But again, regardless whether the OEMs or the fabricators that have provided the numbers, we're seeing a definite increase in the number of holes drilled, which is going to increase costs, and it's going to require investment in new drilling equipment and also potentially more concern on using newer performance type criteria in terms of how the hole looks, the quality of the hole moving forward. As we said, density is also increasing. Finer line widths and spaces, which again drives not just imaging technology and some of the wet chemistry such as develop, etch, and strip, but it's also causing us to look at newer ways and improved ways of imaging the boards. More and more fabricators are moving away from conventional light sources and moving into LDI, laser direct imaging, and also the improvements that are allowing us to move up the technology curve as well. So line widths and spaces are definitely increasing. Now, obviously, what you see here, moving forward, this feature spacing is definitely decreasing, as is the line widths and spaces. So we're looking at this as being another way of increasing wiring density. But again, that puts a significant strain on the processing people, the fabricators who are trying to build and holding these fine line widths and spaces. There's a number of ways, and even in our survey of 2016, all of these technologies you see here, subtractive etch, fully additive, semi-additive, etc., and also use of thin copper foils or ultra-thin foils such as 1/4 and 1/8 ounce foils are all means of adopting or enabling fabricators to get to those finer line widths and spaces to minimize the etch factor, the undercut that happens when you're processing thicker copper with the standard subtractive etch method. Now, obviously, you see some differences between North America, Europe, and then, of course, in Asia on how they're getting there. But as you can see, the move towards conventional subtractive etch, where you thin down the copper or you etch the copper to get to your circuit definition, is moving in favor of other technologies such as semi-additive processing, where you're essentially plating on unclad laminate or on a dielectric film. Like in Japan, in the chip packaging industry, you see a lot of Ajinomoto film, which is basically a dielectric film that you can metallize your copper and get a thin layer of copper on. There are some additional technologies out there called imprint patterning, and it's still around. But again, we're seeing more and more of a move towards use of ultra-thin copper foil, basically. And that's does present a handling issue, but nonetheless, it is one way that is emerging to help us with our finer lines and spaces. In addition, now we're seeing the aspect ratios increase, the thickness of the board divided by the diameter of the hole. That is also causing us to have changes in how we not only drill mechanically, but also how we process plating. Many of us are, as we move up the curve in terms of getting better throwing power and getting better uniform distribution throughout the via and on the surface. This requires us to look at potentially periodic pulse reverse plating in place of direct current plating to improve the distribution and the throwing power in these higher aspect ratio boards. That's not going to change anytime soon. We expect these aspect ratios to increase. Indeed, we know people who do back panels are probably up to the 24 to 25 to 1 aspect ratios. And I think you all know some folks out there are doing 30 to 1. That's significant. So there are some outliers out there that are pushing the envelope in terms of aspect ratio. Same thing can be said on the lower right-hand corner there with respect to microvias. A lot of times we would normally see a 1-to-1 aspect ratio, 3 mil diameter blind via and a 3 mil deep via. Now we're seeing 3 mils going down in diameter, going down to 4.5 mils, and we'll see some evidence of that in the next few slides. So that's also pushing more and more strain on our processes. Blind vias are an enabler. High density interconnect. You've all heard it. Many people say, well, hey, it's primarily in Asia. It's primarily for smartphones. Well, that's not true. It is an enabling technology, period. It allows you to increase routing density, enhances your wiring density, and also if you design it properly, you can remove some layers out of the board and enhance the overall performance of your electronic device. So you do see, and again, while much of the industry is one layer down, basically surface to the next layer, we also see a significant growth in going down to 2+ layers. So going from layer 1 to layer 3 or layer 1 to layer 4. So it's very good possibility that you'll be seeing more designs as a fabricator to develop and process circuit boards with these higher aspect ratio boards, and therefore these layers, vias going down to multiple layers. Now, from a OEM standpoint, we did see in the study that the OEMs in the two regions were very similar in their use of buried vias, and you can see that quite clearly. Now, a high percentage of the OEMs specified buried vias today, and more expect to do so by 2023. So the question will be, how do they do this? When they do spec out these buried vias, they typically need to be filled. So they're either going to be filled with resin from the interlayer resin systems, or they're going to use different types of materials like polymeric paste, ceramic filled paste to fill those vias, and then create what they call overplating or overfilling of those vias. So that's an interesting technology that I'm sure will come out loud and clear in the full report. Now, our next slide. This is another very interesting area, and we saw a major trend again where fabricators are being requested by the OEMs and or the designers to stack the vias. Now, much like a smartphone where you see the vias stacked on each other as opposed to having them offset or staggered in the HDI buildup. Now, again, that is certainly a trend according to this sample of those respondents of the survey. But we do want to caution you, and I'm sure many of you are aware of a couple of IPC committees, particularly the interfacial, microvia subcommittee that is investigating failure modes in microvias that we're starting to see out in the industry, particularly with stacked vias, although that is not necessarily the only type of situation going on. And of course, HD PUG, which you know is an industry consortia, has done a significant amount of work on stacked versus staggered vias from a reliability standpoint. So yes, while this is a trend, we caution you to look at the overall picture and read some of the latest papers that have been published. And there is a white paper that was published by the committee and authored by Jerry Magera from Motorola, stating some of these issues that are worth looking into. So be careful on that one and take a close look at your designs and your process. Along with smaller bowl diameters, thicker boards, of course, is the pitch, right? And we see obviously a major difference between the pitch on surface mount devices in North America, Europe versus Asia, Africa, mostly again Asia. The main reason that you see finer pitch requirements in Asia really has to do with the type of technology. There's more IC substrate technology being done in Asia. And with that is finer pitch, which for the BGAs and the via in pad type technologies. So that doesn't mean that North America is not and Europe is not doing this or not capable of doing this. It just means that's the type of designs that are being built in the two different geographies, driving these changes or differences in the pitch. But we do expect in both regions the pitch to decrease as we move forward into 2023, thus necessitating improvements in imaging technology, as we've stated a little while ago. Now, part and parcel to all this is materials. What are the substrate materials now being specified by the OEMs? And of course, materials drive things like dielectric constants, dissipation factors, frequencies, etc. What we see here that the OEMs actually expect to specify more polyimide moving forward, as well as the multifunction systems, which are still being specified for a great deal of the fabricated circuit boards that are in the marketplace today and moving forward. We also see some changes in the use of PTFEs or fluoropolymers, again, for very high frequency microwave applications. So you can see there's a whole load of materials here being specified. There's not much changes there, but we see things like bismuthine triazine, which is BT, and some of the other ceramic filled materials, seeing a higher percentage of those being specified outside of North America and Europe. But again, FR4, the conventional FR4 epoxy, although higher T sub G, higher T sub V materials will continue to be widely used as the king resin system in the marketplace. Our next slide, we're going to look at final finishes. And again, you see the whole gamut there. There are some basic differences between North America, Europe, and the Asia marketplace. You do see a large percentage of OSP being done in Asia for automotive, some telecom mobile phones, less so in North America and Europe. But what seems to be still a major percentage of technology is electroless nickel immersion gold. And also what seems to be continually growing is the electroless nickel, electroless palladium immersion gold, also known as ENIPEG. We see that typically a lot on substrate technology. And also for those who are concerned that they still may have issues on the electroless nickel immersion gold, aka ENIG, but there may be some issues with still with the brittle fracture. So the use of ENIPEG is technically designed to eliminate that or minimize that issue with brittle fracture. We also see a high growth in silver, immersion silver, and there's still a good percentage of immersion tin being used throughout North America, Europe, and also Asia, Africa. So basically, you're going to see and continue to see most likely all these finishes in use. They may be, some may be changing in their percentages over the next couple of years, but there doesn't seem to be any reason for these finishes to be completely out of there. We still see tin lead hotter leveling and lead-free hotter leveling, and that's not going to change anytime soon, although it's a smaller percentage. And again, one of the best slides here is use of embedded components, and we just wanted to show you what people see in this technology. We saw a lot of movement towards embedded, both embedded actives and embedded passives a few years ago, but it seems to have slowed down a bit. And there's still a small percentage of boards with embedded components. Again, this is from the sample size that responded to the survey. So there may be, again, in 2 years from now, when we redo the survey, we may see some changes on these technologies in terms of embedded, but still a very small percentage. Nonetheless, it is good to be, if you're a fabricator, to gain some knowledge on how to be embedded passive and embedded active enabled, and getting the technology on board, if you haven't already, to invest in that type of technology. Also, in terms of capital investment, it's good to run this survey every time as well. Where are the fabricators expecting to put their money in the next couple of years in terms of capital expenditures? Obviously, and it seems to support it from the survey here in terms of finer lines and spaces, finer pitch, higher circuit densities, is getting away from conventional light sources and either improving or adding additional direct imaging technology, basically using laser type imaging instead of photo tools to get finer features. We also see significant investments in automated inspections, and then high density interconnect, which is the capabilities, capacities, plating processes, etc. So you can see where the major technologies here, and notice the embedded technology, there still came up as 20% of those that responded to the survey expect to make investments in embedding technology. So this will be interesting moving forward into the next 2 to 5 years and see how that changes.
Thank you very much, Mike.
Thank you, Sharon.
Yes, and we have time for some questions. So, Andrea, if you could tell us what questions have been submitted.
Yep. So right now there's no questions submitted, so we'll just give it a few minutes. And just as a reminder, you can use your control panel under the Q&A section to submit those questions.
Okay. While we're waiting, I just want to mention that the PCB Technology Trends 2018 study is available in the IPC online store. You can just go in there and from our website and search on PCB Technology Trends, you'll find it. And if you have any questions about the study, you are invited to contact me at IPC.
Okay, so it looks like one came in. Let's see. All right. In case I missed it, could you list some of the updated methods of checking PWB process capability?
I'm sorry, repeat that again, Andrea?
In case I missed it, could you list some of the updated methods of checking PWB process capability?
Well, updated methods are typically, I mean, they're standard audits. If you're I don't know if the person who submitted the question is an end user or designer, but if you're an end user designer, one of the things you would do is visit fabricators and look at what their capabilities are in terms of reliability. For example, there's a number of tests you can do in terms of building a test vehicle that you could then ask the fabricator to process through its entire facility. So you'd be able to check via quality, you'd be able to check interconnect reliability, thermal reliability, conductive anode filament formation or CAF resistance. So by designing the right test vehicle, you would be able to measure significant, measure the capabilities of that particular fabricator. However, that does not replace doing an audit, going in and inspecting how the fabricator makes the board and what process controls they have on site to ensure a high quality product is manufactured each time. So test vehicles are one of them with the reliability test. You can measure the capabilities that way, but also your own external visit to those fabricators.
Thanks, Mike. Another question regarding materials under polyimide. Was it divided between unreinforced film or flex and glass reinforced, or film for flex and glass reinforced?
We did not parse that, I don't believe, Sharon, in the survey. That's probably a good question, because obviously if it's polyimide for flex, it's going to be unreinforced. But if it's for some of the military applications for like a standard rigid board, obviously you're going to see glass reinforced polyimide. So yeah, I'm sorry we don't know that at this point, but that is a good suggestion going forward.
Yes, thank you. I'll make a note of that, and maybe we can get some data the next time.
Okay, how many companies participated? Regional breakdown of respondents.
74 companies participated, and the regional breakdown, I will go back to our slide about that. Here are the participant demographics. On the OEM side, it was almost 60% North America, but we had 19% from China, almost 10% from other Asia, and almost 10% from Europe. One from Africa, as I mentioned, South Africa, actually. On the PCB side, 45, almost 46% from North America, about 23% from China, 9% Japan, about 14% other Asia, and 9% from Europe.
Thanks, Sharon. This is probably a question for me. Will this WebEx be available for download, demand viewing? Yes, the link will be sent to everybody after this webinar concludes. Next question, what was the name of the author, Motorola, who has a paper on microvias?
His name is Jerry Magera, M-A-G-E-R-A. You can get that paper. It's a white paper that was put out with, we have a committee at IPC called the Technology Solutions Committee. And one of our goals, and I chair that committee, one of our goals was to take important topics to that are needed in our industry to get better understanding. And we took the first topic as tackling microvia failures. It was a call to action, and Jerry had done significant work on getting an understanding of where some of these problems are, which now necessitated an entirely new group of folks, studying this problem with a new subcommittee under the TSL. So you can get that white paper through IPC.
Thanks, Mike. Another question, can you touch on the respondents to the survey, especially in NA/Europe versus Asia/Africa, and what types of technologies the respondents supported, i.e. daughter card, line card, back plan, MCM-L, etc.?
That's going to require a little bit of digging through the data. This is not published in the report, but we do have their primary end product identified, the type of products that they make, and their vertical end product markets. We can certainly provide a list. Oh, here we are. Hang on, I'm just looking through the report right now. Well, it's a long list. I mean, everything from automotive, aerospace, radar, military, missiles, test equipment, energy equipment, radios, routers, switches, medical devices, building efficiency, let's see, wireless, computers, water quality testing and instruments, consumer electronics, tablets and handheld devices, HVAC controls, mission critical power supplies, display panels, landing systems, encryption devices, power distribution units, flow measurement, video streaming devices, electronic controls, temperature controllers, sensors, controls and lighting, network, wireless, energy and IT, industrial PCs, telecom, carrier class equipment, and data center products. Those were some of the types of products referred to by the OEMs. As far as the breakdown of that list between Asia and Africa versus North America and Europe, I think that is something we would, let's see, something we would have to dig out. I'm not sure it is. Oh, here we have it. Okay. We do have it in the report. So for Asia and Africa, the OEMs mentioned sensors, controls, and lighting, network, wireless, energy, and IT, medical, power, automotive electronics, industrial PCs, automotive entertainment systems, carrier class telecoms equipment, test and measurement equipment, data center products, and missiles and UAVs. And in the European section, North America and Europe, I should say, if I can quickly read this list, they cited automotive test equipment, energy, two-way radios, military radar, routers, switches, medical devices, building efficiency, electronic management module, water quality testing, single board computers, consumer electronics, tablets, handheld devices, HVAC controls, aerospace, mission critical power supplies, tablets, display panels, landing systems, radar, power distribution units, flow measurement, video streaming, power units, electronic controls, and temperature controllers. I hope that helps.
Thanks, Sharon. Going back to the paper, is the Motorola paper you mentioned related to the update of the IPC TM650?
No. It is not. No. I think you should get the paper and take a look at it. It's like it was the first of the Technology Solutions Committee to take an issue, like I said, and that was the first one since it was the one that getting the most interest. If any of you out there who are also part of HD Pug, the consortia, which we are, there's some interesting work that has been done as IPs or as HD Pug members, you'd be able to access some of the reports that were done on stacked versus staggered vias and micro via reliability. But there's a great deal of information published out there on the latest in terms of micro vias. So I think it really would behoove you to get involved if you're not already.
Thanks, Mike. And then another question, is there any information available on coating technology and protective technologies in the future regarding nano coatings or other materials to be applied? We are seeing more UV and two-part technologies being released.
Well, a good question. I think maybe that would be elsewhere in the report. You're talking about conformal coatings, and you're talking about some of the parallenes and some of the other nano coatings, as you call them. We do see some I do see in my travels globally some emerging trends in the use of nanotechnologies to protect circuit boards that are different than your conventional conformal coatings. But nonetheless, conformal coatings tend to be growing significantly, particularly for harsh use environments. So I don't know if that helps answer your question, but I'm sure there's other areas of the report that when you take a look at it, you'll see this information has been addressed as well.
Thanks, Mike. And then another question just came through. Could you elaborate a little more on what HDPUG is?
Yes. HDPUG is a consortium that was formed over 20 years ago. There's about 75 member companies. HDPUG, and you can look at it as HD as Harry, David, Paul, U as an umbrella, G, HDPUG, High Density Packaging User Group. It's a consortia, so hdpug.org. You can look at that. It is an industry collaborative, basically. Companies become members, and they work together on projects to solve problems. It's kind of a in-kind type resource. So there might be 5 or 6 companies working on a particular project, and they work to design the project, get test vehicles built, test various things. For example, one of the projects that HDPUG just concluded was an evaluation of laminate materials under harsh use conditions. They went through and they evaluated 25 different laminate materials and published the findings on things like reliability, calf resistance, thermal decomposition, etc. So we're very above board, not a sales pitch type thing. Everybody kind of worked together, and it becomes useful information for those in the industry to see where these materials stack up under these conditions. So that's if you have a chance to look at HDPUG, and if you're not a member, if your company's interested in being a member, I think you should contact HDPUG. It's very worthwhile, in my opinion.
Thank you, Mike. And we've received a few questions about if the presentation will be available. Are we able to share this presentation with everyone, Mike and Sharon?
Yes.
Okay, perfect. So what I will do is I will make sure it's included in the post email that will have the link as well.
I'll send you a PDF, Andrea, and you can send that out.
Perfect.
All right.
That is all the questions that we have received.
Well, thank you very much, Andrea, and thank you, Mike, for an excellent presentation. And thank you all for joining us today.
Yes, thank you.
Thank you.
Goodbye.